Okay, I'm doing question 6, the question that I promised to do, right? So I want to explain a concept before I move on. Just a quick concept. The zeros or roots or x-intercepts of a parabola are the points that intersect the line y is equal to 0. The line y is equal to 0 is the horizontal axis, right? Right, so the line y is equal to 0 is the x-axis, the horizontal axis. That's what we're talking about. We're not talking about the line y is equal to 0. And then the vertical line is actually x is equal to 0. That's what it's called, right? Let's move on to the question. It says given f of x, which is equal to ax squared plus c, where f passes through the x-axis at, let me write this down because it's interesting, right? 6.1. So this parabola passes through the x-axis at d minus 5, right? And d minus 1, where d is an element of real numbers, right? So what you're given here are the roots. You're given the roots or the x-intercepts of a parabola, which are the points that are right here, right, on the x-axis, right? The x-axis is also equal to the line y is equal to 0. So the equation of the x-axis is y is equal to 0. This is equation 1, right? And in the definition right there, I said these points are actually right here. They are there. They are there. They touch the x-axis. These points touch the x-axis. That means one thing. These points are actually equal to the x-axis. Do remember when we discussed this? F of x is equal to g of x, and we drew a parabola and a linear function. We said f of x equal to g of x happens there, and there. It's the same thing that is happening here. So these points are actually equal to y is equal to 0, right? That is why when we're looking for the values of d, just like the question said, we should look for the value of d. We will say d minus 5 plus, we are adding this because that's the only thing that we can do. We cannot say d minus 5 is equal to d minus 1. You are saying these x-intercepts or these roots are equal. We don't know because our parabola could be like this. Let me draw something right there, right? It could be like this, right? It could have an x value right there at the origin. Do you see the origin? And also an x value which is going to be negative. So it could have an x value which is equal to 0 at the origin, and also an x value which is equal to negative 5, right? Somewhere right there. Okay, so that's why we cannot say d minus 5 is equal to d minus 1. So the only thing that is mathematically correct, remember in mathematics you can use whatever trick that you know as long as it's mathematically correct. If it's mathematically correct, your answer will be correct. We are following mathematical procedures. That's all we're doing. So we're adding these roots, right? What did I say? I said your roots, your x-intercepts are basically zeros. That's what we're saying. They're just zeros. So we'll say equal to 0 right here. Why? Because your x-intercepts, right, they actually touch the x-axis. So your x-intercepts are actually equal to 0 or equal to y. But y is not convenient because y is the same thing as 0. So we'll say your d minus 5 plus your d minus 1 is equal to c. I need a new pen. So you have this, which is equal to 0, right? We are doing this, we're equating this to 0 because we're talking about your x-intercepts. Your x-intercepts are roots. They are also called points on the line y is equal to 0. So that's why we're equating this entire thing to that. That's why we are doing this. I'm not doing this because it comes from my head. I want to. Okay, no, it doesn't work like that. So let me make another example on the side so that you can understand. So what do we have there? We have a parabola, right? Which is equal to that, right? This is just a parabola. So when you want the roots, the x-intercepts, what do, right? I've told you when you want the roots, the zeros, or the x-intercepts, these three things are actually one thing. It's like the Holy Trinity. Jesus, God, Holy Spirit, that's one thing. It's the same thing here. So you'll equate this to 0 because you're looking for the zeros, the x-intercepts, or the roots. So you'll say 2x squared plus 3x plus 1 is equal to 0. And then you look for your x values, which your x values are zeros. That's why they are equal to 0, right? I hope you get that point. Let's go back to the question. So we do some algebraic manipulation. We do this. Then d plus d, that's 2d. Then this is going to be negative 6 equal to 0. Then 2d is equal to 6. We divide by 2. Divide by 2. Then d is equal to 3. Right, so we have d right there, which is equal to 3. And we have 6.2, which says determine the values of a and c if it is also given that f of 1 is equal to negative 9. So f of x is equal to b. This is the standard form, right? X is the input. B is the output. So the same thing happened here. You input, is it 1? You input 1s, right? And then your output was negative 9. So do you see it's the same thing, right? So what you're given here is additional information that you'll use. You are given your x value, which is equal to 1, and your y value, which is equal to negative 9. Remember, for a function to exist, for every, let me write this down, for every x value, there is a y value. That's the definition of a function. Wherever you go, if this definition does not apply, then it's not a function. It could be a circle, it could be a rhombus, it could be a parallelogram, but it's not a function. A function needs an x value. That x value needs to have a y value. That's what we're talking about. So you're given two things here, an x value which has a y value, which is negative 1. So we read the question. The question wants the values of a and c, right? So I want to show you something, right? This, I'm pretty sure you're wondering what this is. This is the x-intercept form. We call it the x-intercept form of a parabola. You use this when you want the value of a, when you are given the roots, the x-intercepts, the zeros, right? That's when you use it. And you will find the value of a. Bear in mind you are given x, which has a value of y, which is negative 9. So your negative 9 is going to be there, and then your 1 is going to be here and here, and then you are given the roots, right? The roots, the zeros, the x-intercepts. I'm saying they are roots, zeros, or x-intercepts. That's the same thing, right? Remember, we had to find d, and d was equal to 3. And then we were told that f passes through the x-axis at d is equal to negative 5. they were actually giving us the x-intercepts, zeros or roots. So your first x-intercept is actually equal to d minus -5. We know that your d is actually 3 minus 5 is actually 3, so we have 3 minus 5, so your x is -2, and then we know your x is equal to d minus 1. Your d is 3 minus 1, so your x is equal to 2. So this is your parabola. Your parabola has 2 zeros, 2 x-intercepts, 2 roots, right? 2 x values. So these are your x values for your parabola. So you plug in these roots, x-intercepts, zeros right there at R1 or R2. My point is, it doesn't have to be R1 or R2. You can use A1, A2. It's just standard procedure. It's nothing important, right? So let's solve this. So what I did here was substitute the -9, which is the y value, and I substituted the 1, right? We were given this point, f of 1 is equal to -9. I decided to sub it in, right? Right here is -9, 1, 1, right? And then we have the x-intercepts, which I found were equal to -2, and x is equal to 2. We actually put them right there and right there. It doesn't matter if you put -2 right there or 2 here. It doesn't matter, right? So we solve, right? This is 3. That is -1. So it's going to be -3. So your -9 is equal to a. -3, you divide by that, you divide by that. Your a is going to give you 3. -9 divided by -3, that's positive. That's a is equal to 3. And we found the value of a. Now we want the value of c, and our equation was f of x is equal to ax squared plus c. We know the value of a is 3, right? F of x. Remember, we're given a point. Whatever. Listen, this is a trick. Very good one. These guys, they don't like wasting time. They don't like talking too much. If they give you something, just know you're going to use it. If they tell you that the shape has 2 equal sides, a, b, and bc are equal, those sides are equal, know that you're going to use that. They don't say anything just for fun. They don't do that. So we'll get in, right, with this. And then we have 3, 1 plus c, it's -9. Then 1 raised to the power 2 is 1. You know that, right? So we transpose 3, c. So your c is equal to -12. So your equation is, you are done, by the way. You find the value of c and a. I'm just doing this for fun because I like it. So it's 3x squared minus 12. You don't have to write that equation right there. Okay, so yeah, I'm done. So the key thing in this lesson was the roots which are the x-intercepts which are the zeros. I hope you understand that. It's going to help you a lot. Like, it's going to be there forever. So yeah, I guess we're done.